Hi, welcome to Factoring Polynomials. I'm your host, Mrs. Henry. Today we're going to factor a higher order polynomial. And first, before we factor anything, we have to remember to take out our greatest common factor. So our greatest common factor is here, is c. So I get 125 c cubed plus d cubed. Now, what do we know about 125 c cubed and d cubed? Oh, you're right. They're both perfect cubes. So we have to break them up in a equals 5c and b equals d. And we're going to plug them right into the formula over here. So when I plug them in, I get 5c plus d. And then I get 5c squared minus 5c times d plus d squared. And if I simplify this, I get c, 5c plus d, 25c squared minus 5cd plus d squared. And we have factored successfully a sum of cubes. Questions on that? Ooh, do you hear the crickets? Now let's move on. Now I'm going to remind us that when I have cubes, that I'm taking the difference of cubes. Remember, when we find the cubes, we have the same sign, the opposite sign, and always positive. That's what our signs are for cubes. So now we're going to look at another example. So I have p to the 6th q to the 4 minus q to the 7th. And here, the first thing we have to do is take out my greatest common factor. My greatest common factor here is q to the 4th, and I get p to the 6th minus q to the 7th. Ooh, minus q to the 3rd. Sorry about that. So a equals p squared and b equals q. So I have q to the 4th equals, remember we have same sign, different sign, always positive. And so I have a minus b, and I have, oops, this should be b. So then we have, when I combine like terms, I have p squared minus q, p to the 4th, plus p squared q, plus q squared. And that's how we factor that. More questions? Nope. Remember, when we factor, we always look for the greatest common factor first. The GCF here is 5. So I get a to the 4th minus 49. What do we know about a to the fourth and 49? They're both perfect squares. I'm going to go over here and write another formula. If I have a squared minus b squared equals, hello? Okay, and now if I take the square root of 49, I get a squared plus 7, a squared minus 7. Can either one of those be factored further? Nope. So we're done. Now I have a to the fourth minus 3a squared plus 2. Now 1 times 2 is 2. So what multiplies together to give me 2 and adds together to be negative 3? So what multiplies together to give me 2 and adds together to give me negative 3 is negative 2 and negative 1. So I get a squared minus 2, a squared minus 1. What do I know about a squared minus 1? You're right, this is perfect cubes again, or difference of cubes again. So I have a squared minus 2, a plus 1, a minus 1. I'm going to do probably 3 more examples with us. So now I have 5x to the fourth minus 10x squared minus 3/15. So my greatest common factor here is 5x, or 5. So I get x to the fourth minus 2x squared minus 63. Now what multiplies together, because 1 times negative 63 is negative 63, multiplies together to give me negative 63, adds together to be negative 2. Oh, you're right, negative 9 and 7. So I get 5 times x squared minus 9, x squared plus 7. Here, do you notice anything interesting? You're right. Right here can be factored again because they're both perfect squares. So the square root of x squared is x. The square root of 9 is 3. So it's x plus 3x minus 3. X squared plus 7. There we go. 2 more examples. Now I have 8n to the fourth minus 2n squared minus 1. This step is going to be a little bit different because the number in front of my highest degree term is not 1. So what multiplies together to give me negative 8, but adds together to give me negative 2? That's going to be negative 4 and positive 2. So I have 8n to the fourth minus 4n squared plus 2n squared minus 1. Notice how these two add together to give me here. So I haven't really changed anything. The GCF of these two is 4n squared. So I get 2n squared minus 1. The GCF here is positive 1. So I get 2n squared minus 1. What do they both have in common? 2n squared minus 1. And what's left over? 4n squared plus 1. Now we're going to do one more example. And it's going to look a little bit different. But I'm going to use the same process we've been using for months now. X to the 5th plus 5x squared, 5x to the what power? Yep, 5x squared minus 4x cubed minus 20. My GCF here is x squared, so I get x cubed plus 3. The GCF here is negative 4, so I get x cubed. Ooh, this should be not plus 3, this should be a plus 5. Plus 5. They both have x cubed plus 5. I'm left with x squared minus 4. What do you know about x squared minus 4? Those are the difference of squares. So I have x cubed plus 5. What's the square root of x squared? X. What's the square root of 4, 2? One's positive, one's negative. I know we've been doing this for a while and this is what we did the week and a half before break, but happy factoring.